All right, we're now going to take a look at combined systems, which are very similar to the way we solved linear systems of equations back in the fall, except instead of having just lines, we're going to be taking a look at when you have ellipses, circles, parabolas, lines, hyperbolas that intersect each other. And we can have multiple intersections. Back when we were doing lines, the solution was only one point. Well, with a circle and an ellipse, for example, you can have 4 points of intersection. That doesn't mean there will be 4 points, but there can be up to 4 points of intersection. So those are what we're going to be looking at. 3 methods for solving our combined systems. One is going to be elimination method, which is the same method we used back in the fall for lines. Another method is graphing, which again we did back in the fall. And then the third method is substitution. So these are the same 3 methods that we did back in the fall with lines. So the process should not be a whole lot different. Now, when you have your system right here, first recognize what type of conics that you're dealing with. X squared plus y squared equals 20 is a circle. 4x squared plus y squared equals 68 is an ellipse. So that's what we're looking at, a circle and an ellipse, and looking for the points of intersection. With elimination, as the name implies, we need to try to eliminate one of our variables. And that comes through addition, or adding the 2 equations together. So if I want to cancel out the y squareds, for example, or the y's, this is a positive y squared, which means I need to have a negative y squared right here. Okay. Now, in order to get those to cancel out, I need to multiply one of my equations by negative 1. This equation now becomes negative 4x squared minus y squared equals negative 68. This equation, we didn't do anything to it, so it's going to stay the same. All right, we now are going to take those 2 equations and add them together. All right, well, 1x squared minus 4x squared is a negative 3x squared. Positive y squared, negative y squared, those will cancel out, equals negative 48. So you're now we are now going to divide both sides of this equation by negative 3, which will give you 16, and then take the square root. Remember that whenever you take the square root, you always will have a plus or minus in front of whatever the square root is. All right, so x is equal to plus or minus square root of, or plus or minus 4. To get the y value, you now take this and substitute it back into one of our equations. I'm just going to take this and substitute it back into x in this equation. All right, so let's start with the positive 4. 4 squared is 16 plus y squared equals 20. Subtract your 16 to the other side, which will give you 4, and then take the square root. Now, remember that taking the square root means you will get a plus or minus 2. So whenever x was 4, I could either get a positive 2 or I could get a negative 2. So now we do the same thing with the negative 4. Now when you plug negative 4 in, negative 4 squared is still going to give you positive 16, which means you would end up with the same answer here. Well, this time we substituted negative 4 in for x, and we got the same results, positive 2 and -2. So there are 4 points of intersection for this graph and this graph. All right. Let's take a look at the next example here. We need to pick which variable we want to cancel out. But if you'll notice here, these two are not lined up. So let's get the x squareds lined up and the y squares lined up. So doing that, this will become -27 x squared plus 6y squared equals 54. And this is 9x squared plus 5y squared equals 45. See, now everything lines up, x's on top of x's. The variable that would be easiest to cancel would be our x squareds. We can do that by multiplying this equation by a positive 3. When you do that, you get 27x squared plus 15y squared equals 135. The bottom equation, we're not doing anything to it. Now we add our two equations together. When we do, the x squareds cancel out. 15y squared plus 6y squared is 21y squared equals 189. You're going to divide by 21, which is 9, and then take the square root, which is a plus or minus 3. So just like before, we're going to take this and substitute it into y into one of our equations. It doesn't really matter which one. I will take it and put it into this one right here. All right, so doing that, you're going to get 9x squared plus 5 times 3 squared is 9 equals 45. That means 9x squared plus 45 equals 45. That's going to end up giving us a 0 when we take the 45 to the other side. Dividing by 9, 0 divided by 9 is 0, which means x is 0. Notice we don't have to put a plus or minus on the 0, because it's neither positive nor negative. So if I put a 3 into my equation, I get a 0 as a result. If I put -3 into my equation, -3 squared is still positive 9. So we will still end up with the same result when we use -3. Okay, let's go on to graphing. With graphing, first thing you want to do is identify what types of conic sections or graphs that you're dealing with. This one, since the y's are not squared, but the x's are, this is a parabola. This one doesn't have anything squared, so this is a line. So we're looking at the intersection of a parabola and a line. Well, parabola is either an x equals equation or a y equals equation. In this case, it's going to be y equals. Take the 2 over to the other side. This will be our equation that we type into the calculator. On this one, subtract the x, and then divide by -1. All right, so these are the two equations we type into the calculator. And when you put those in the calculator, this is the graph that will be generated. All right, you then go to finding the intersections, and the intersection is going to be 8, 2 and 4, -2. So that's all you have to do is write those down. Those are your solutions. Now what does that mean? That means that 8, 2, when I put it into this equation, will give me a true statement. 8 is the x value, y is the 2 is the y value. So it means 2 equals 8 minus 6. Yep, that's true, because you get 2 equals 2. You could also put it in right here. 2 equals 1/4 times 8 minus 4 squared minus 2. 8 minus 4 is 4. 4 squared is 16. 1/4 times 16 is 4. 4 minus 2 is 2. So you can see that point works with both equations. The same would be true with 4, -2. All right, let's take a look at the next one. This equation is a line with an equation of y equals -2x plus 10. This is another parabola. So when you put both of those equations into your calculator, this is the graph that you get. X equals is a graph that opens to the right. It's a horizontal orientation. Because the a value is positive, it opens to the right. And when you do the intersection, it's right here, 2, 6 and 8, -6. Now, if you're not sure where to put things in the calculator, go to New Document. Always don't save. Go to Graph. And on the calculator, you can put your conic sections in by going to the Menu button. Go down to Graph. Go down to Equation. And you'll notice here are your conic sections. For example, the parabola is right here. You have y equals equations and you have x equals equations. This particular problem was an x equals. So you would come and select this one right here. And you just type it in. You have 1 divided by 8 for the a value. 2 is the k value. And there's no value out here on the end, so you just insert a 0. And that gives you the graph that we saw earlier. Right. And then you would press Tab, bring up your equation line. But this time we need to type in our function. This is just a regular function, so we go back to here, select function. Type in -2x plus 10. Then to find your intersection, go to Menu, Geometry, Points and Lines, Intersection Points. Click on one graph, and then click on the other graph. And the points of intersections show up. Now all you have done in that process is you have told the calculator which two graphs that which two equations or graphs that you're trying to find the intersections of, and it finds it for you right there. All right, let's go on to our last process, which is substitution. Now in this process right here, or this problem, what we're going to do, there's lots of different ways of approaching this. What you want to do is look for some commonalities. If you notice, both of these equations have an x squared. Right here and right here. So if I solve one of my equations for x squared, I can put that in place of the other x squared. This equation has a y squared, but this one does not. So I cannot do that process with the y squareds. I can't do it with y either because this equation does not have just a y by itself. I could, but it was going to make things difficult because we would end up squaring a number that's already squared. So you end up with a fourth power, which becomes a little bit more complicated to deal with. All right, so if I want to solve for x squared, I can multiply everything in this equation by -4. This becomes -4y. This becomes plus 25 equals x squared. This right here is equal to x squared, which means anywhere I see an x squared, I can replace it with this. So we're going to do that. -4y plus 25 equals, plus y squared equals 25. This is a quadratic equation, so we need to set it equal to 0. The 25s will cancel out. Our next step is to factor. Factor out a y. And the value of y that makes this 0 is 0. And the value of y that makes that 0 is 4. All right. So we'll start out. Y is 0. We're going to plug it in. Now, which one do we plug it into? In this particular problem, it doesn't matter. When I plug 0 in for y right here, which is probably the easiest place, you're going to end up with x squared equals 25. Which means x is going to equal a plus or minus 5. So you get a positive 5 and a negative 5 when you plug 0 in for y. Now, if I had plugged 0 in right here or right here, I would end up with the same answer. So it doesn't really matter. Now, if I plug 4 in, 4 squared is 16. I'm sorry, 4 squared right here, 16. Subtract that 16 to the other side. You get x squared is equal to 9, so it means x is equal to plus or minus 3. And you get the same answer if we put it in right here. All right, so when y is 4, you get a 3. And when y is 4, you also get a -3. 4 points of intersection. All right. And the last problem. In this particular problem, this equation has an x squared, this one does not, this one has a y squared, this one does not. So I'm going to solve for y, which would be equal to x plus 4, and take this and put it in place of the y right here. So that will give us x plus 4 squared minus 4x squared equals 16. When you square this, x plus 4 times x plus 4, and FOIL that all out, you get x squared plus 8x plus 16 minus 4x squared equals 16. Well, if you notice, we have a 16 on each side, so those are going to cancel out. You get negative 3x squared, combining like terms here, plus 8x equals 0. We can factor out an x, which will give us negative 3x plus 8. And so our solutions, x equals 0 for this one, and for this one, if you take the negative 3x plus 8, set it equal to 0, you end up with x equals 8/3 is our other solution. Okay, so if I plug 0 in for x, now this is one where you have to be careful. If I plug 0 in for x here, you're going to end up with this term canceling out, and you get y squared equals 16. Well, that would mean y equals plus or minus 4. But if I put 0 in for x here, it means y only equals 4. And remember that your solutions have to work for both equations. Well, the only y value that is in both of them is a positive 4 for the y, because this was plus or minus 4. This one is just positive 4 when you put 0 in for the x values. All right, so we're going to do the same thing with 8/3. Well, if I put 8/3, I'm going to end up with a plus or minus value again. So I want to put it into the one right here. This is a linear equation. So if I put 8/3, well, 4 is equivalent to 12/3. So 8/3 plus 12/3 is going to give us 20/3. That will be our solution. All right.